All right, my name is Stefan Bayer. It's my distinct pleasure to be the moderator of this masterclass. Feels great to be on stage here and see so many familiar faces down there in the audience, and I hope you find this interesting. We're trying to contribute to the discussion today that we already had and trying to advance it. Now, the title of this masterclass is Boosting AM with Big Data, Physics-Based Software, Circularity, and Platformization. So that's a long title, right? Why did we choose this title? Because we wanted to investigate a hypothesis. And the hypothesis is really around customer value. We talked a lot about that already, but we feel that we're not getting there enough with the AM technology today. So what does it take? We believe that AM will only be adopted when multiple technologies come together, the concepts fuse, and that will together then maximize customer value. And in order to investigate that, we have three distinct panelists today, which are going to share some of the inside views, and I think you're going to find them very elusive. And I'd like to present to you Alexander Oster, who is Director of Additive Manufacturing with Autodesk. He's going to talk to us a little bit about platformization and how to disrupt AM with this. We have with us David Hartmann is CEO and founder of Helio Additive, a great software company that's based on pure physics. And we're going to look into the technical and commercial potential of AM using this kind of software. And thirdly, we have Phoebe Blackburn with us, who is the founder of Phenomenal Words and our expert for circularity, a concept that has not been introduced to AM a lot. So we want to introduce it today. And you're going to talk about circularity and how circularity can help to boost AM. So it's my great pleasure to have you here. I'm really excited to see you on stage. We're going to have 3 rounds of presentations followed by questions. So I invite you all to participate via Slido. I also like to introduce then my co-moderator, Tim. Tim Fenner is a senior project manager with Roland Berger. He's also going to share some of the practical insights from your consulting work, and we're both going to moderate the questions and the session. So thanks to you all for being here, and then without due delay, Alexander, over to you.
Right. Thank you for the invitation, and thank you for being on this panel. I would like to talk a little bit about platformization and the Autodesk point of view on additive. First, we'll give a high-level introduction. Then I will talk a little bit about some tales on the commercial side of things, and then I just want to quickly wrap up with an outlook. I will skip through my slides quickly because it's actually an hour presentation condensed in like 10 minutes, so apologies if it's too confusing. But I think it's a nice story, and I really wanted to tell it. And I don't want to bore you in total, but I just wanted to give a little bit of overview of Autodesk because it's very much underestimated the size of the company in this industry. So Autodesk is one of the biggest software companies on the planet. We are active a lot in mechanical design, but in very many industries. For example, Alias is used for designing almost any car in the world. Revit is used for designing almost any skyscraper in the world. And Maya and Max are used for making almost any movie and video game in the world. And we make like $5.5 billion revenue with like 12,000 people worldwide. And as that, and I can tell you as being part of a 1,000-people engineering organization that works on one software product, we know software is really hard. And it's not only hard, it's also really expensive if you look at it. And it's even harder for machine vendors who usually don't have a core. Usually their core business model is not around software, it's an add-on, and that we see again and again and again and again. And if you look at the industry, there is something what I call glorious past. This was like 5 years ago. And the bleak present, and in the past we had 0 interests. Today we have non-zero interests. What I have seen so many pictures of startups doing additive is TAM is manufacturing, and if you have gazillions of dollars of potential revenue, then what you invest in software doesn't matter because it always will pay off with numbers. Today the landscape is increasingly competitive, and there was not the explosion because hardware is also expensive, hard and expensive. But if TAM is manufacturing, then you always have exponential growth projections, which have gone away in the industry, and everybody has a headache from the party, I can say. If you were at AMAC, I think that was very prevalent. And what happened is And we saw that as software vendor dealing with hardware vendors before, every little features they had 5 years ago was a differentiating asset, even if every other vendor in the industry did the same thing. And that has gone away. So what hardware vendors especially are going is software is becoming an OpEx liability because you have to pay software engineers developing standard functionality that does not differentiate you. And if you have too much OpEx liability, that is how your stock price looks like. And I have this joke that half of the audience will now get a shock and say, is this my stock price? And I don't want to tell which company that is, but everybody looks similar. And if you look at the mobile phone industry, there's a huge differentiation because a multinational software company was adjacent to the industry, created a software stack that, besides from Apple, every phone user could use to have a base platform that they could differentiate their core specialty in. And what we want to build is an Android equivalent for industrial additive manufacturing systems, which we call Autodesk Machine Control Framework. And the idea is that we take the Autodesk software stack, combine it with component manufacturers like ScanLab, I think, sitting here in the audience and are very helpful with it. But also other vendors like PLC vendors, like B&R Automation, we work a lot with. And then combine all that together that you can take off-the-shelf components on hardware and software and then just do your development that differentiates you, like your mechanics and so on. Maybe in a CAD systems that we also can provide, and create the software stack. And I will just show you how this would operate. So if you use our core product, is Autodesk Fusion, it's only $2,000, and you get CAD system, you get data preparation, nesting, support, structure generation, toolpath generation, process simulation, everything you need end to end. From the software side, you can just buy it online, $2,000. Then you take our software stack to control the machines, and that does all the process control, non-real-time control on a PC. Goes to the individual off-the-shelf components, like the ScanLab components, like a B&R PLC, and so on, and then you can print parts. But you not only can print parts, you can take off-the-shelf components and do data acquisition and do process monitoring with it. You can just buy that. You can just get a quote and buy that today. You push this back in the system pushes back to the CAD system. We have a process simulation, so for example, you can get a full thermal temperature history of your process and overlay it with your simulated thermal history of your process. And then you do some decisions on it, and what decisions you make is the differentiating IP, not that this is possible, this is just an engineering task. And then you do a closed loop, so you basically can either change the toolpath, change the orientation, change anything upfront. You can do it online, like non-real-time as a layer-by-layer basis, or you do it like real-time, like a PID control on the power and so on, and I can just say ScanLab has amazing off-the-shelf solutions, like the open interface extension that allows you to regulate for temperature and not for power, for example. And this is just an example. What we deliver is a platform that you can choose what you want, either on the data prep side, the machine control side, whatever. Just take it at a very low cost that millions of users can access it, and then just build your ecosystem. And if you look at a commercial point of view, what usually happens is a machine vendor starts up either as a startup or an incubation board in a large OEM, and they have 3 PLC programmers in their team, and one of them knows C# by accident or statistics, and that's the guy who does the software implementation. And they start in the first year, they ship the first machine, it prints parts, everybody's happy, get Series A investment, scale up, and then the second year comes. And in the second year, something unforeseeable happens, which is a second machine is sold. And I've never seen a machine vendor whose second machine is the same as the first machine, so immediately come into version management issues and so on, and all the things that software comes, and then at some point in time, you find out that there are CAD companies on the planet, and MES companies, and on and on and on. And then at some point, you find out that you cut off so many development paths in your development cycle that you're lost. And you either start from scratch, like big companies can do, or you have a real problem in implementing new features. And the problem also is you already invested tens of developer years on your system, and you can't change it anymore, and that is the trap a lot of people run into. And our pitch is, from the platform side, all the things on this slide, you get for $2,000. And that's a really nice value proposition, especially if you look at the productivity boost. So all the things I said before are easily 32 developer years you can waste easily on this, and you won't get there. And you won't get to everything because you will organically grow it. The idea is, and we have proven this with first vendors, is that you can cut this down to 2 developer years very easily. because you have 3 developers for 8 months. And that's not only that you can cut it down to developer years, which is millions of dollars that you save. It's also you cut down the time to market because you only need 8 months to do the software. And then if you multiply that, which my bosses in San Francisco like a lot, it's almost 100. And I don't know if that's scientifically accurate, but it's almost 100. And then what we do is, because it touches the core of a machine vendor, we don't do a business model on it. We just went to the 3MF consortium with the Linux Foundation and open sourced the whole stack. Also everything that's not Fusion. 360 is all the machine control stuff. And that is really powerful because even if it's open source, everybody can adopt it. But it's BSD licensed, and the people you know the details about license management is, it doesn't mean that your machine needs to be open source. It means that you can take it and closed, make a proprietary system on top of it that differentiates you. It's just that we don't have to deal with. And I don't have enough time, I only have 2 minutes left, to deal with all of these things. I have a long list of reasons why this is really important. Otherwise, you are lost if you make yourself dependent on a third-party vendor for your crown jewels. And that's very compelling when we talk to machine vendors. And then there are other things that only a company like Autodesk has. I always say that we probably don't know how to develop software, but we certainly have learned how not to develop software, and all of these things went through the system. And I have a few case studies. I first want to talk about the academic ones because they're really great. So here, this is Laserzentrum in Aalen. They had like 2 people develop this system, which is a closed-loop, real-time controlled system. I can't go into details. I only have 1 minute left. But it's really amazing. So it does a mate pool monitoring. And you see even in the image here, you see that they even messed up because they printed on the screw, and you see in the thermal history. And they not only measure what's happening in the mate pool, they also do a closed-loop control with the ScanLab components. And with the Technical University of Munich, we went even further. We designed a fully open system where TU Munich designed the CAD in a system that they trust. V&R Automation was very helpful in helping us design an open source PLC software, and we made the machine software. And we will just release it, I think, in the fall. We will just release it on our website that everybody can use it for research purposes. That's not for commercial use. That's very research focused. But the idea is to create like similar that RepRap did for the FDM printers, that we create something that innovation can go much quicker. And if I have 30 minutes left, I think this will just disrupt a lot of things in industry. One thing is new machine concepts will come. And I've worked with a startup that fortunately was bought by Nikon SLM Solutions called Additive, which do a 5-laser, multi-laser moving source machine for 1 × 1 meter parts. It's really amazing. And they could implement the machine software with 1.5 developers in 8 months. Low-cost machines will come because the cost per part are too high. There will be a split between the high-end one on the left, which are ultra-large, and the low-cost machines. One Click Metal is my favorite customer. They, of course, have their own, and I think Garrett is in the audience. They are amazing. They will change a lot of things with a mass market approach. They have their own machine software stack. That's not the question, but our platform approach is that when you have expertise in an area, you can use yours. We just offer you an end-to-end solution that you can pick what you want. So that's one thing. And they sell a machine for $90,000 that makes really amazing parts, I can just tell you. We own one, and it's really amazing. Then there are retrofit machines. You could buy a cheap machine from One Click Metal, and that's what we did with One Click Metal, and we bought just standard ScanLab components and just retrofitted it to be like a closed-loop controlled machine for a few $1,000s more that has really the highest end components that ScanLab offers. That is really exciting because you can do beam shaping, closed-loop control, dual laser, synchronization, all kinds of things for very, very competitive price. We work a lot on the high end, on the tool passing with multi-material. So there is, I think Christian Seidel is also in the audience. They did an amazing thing on the Fraunhofer with the multi-material printing. That's what is Formnext all the time. And that is just the beginning because we just, and I think Omar is also in the audience. If you have all of this and have full control over what's happening on the machine, you can really go the AI-driven way. And Amaze is really amazing. I was a bit skeptical in the beginning, but when I look more into it, it's just like the most, how would I say that, credible solution. Maybe next to David's, but David is polymer. The most credible solution in the AM space that we have seen of AI so far. So thank you, and I'm sorry for taking 2 minutes too long.
Don't worry, don't worry. I already see that there's questions coming in, if you all agree. This is your round of applause.
Thank you.
Sorry for that. If you all agree, we'll do the Q&A afterwards. And then, David, I think you're up next, and looking forward to your presentation.
Yeah, thank you. Good afternoon. Yes. So good afternoon. My name is David Hartmann. I'm the CEO and founder of Helio Additive. And what I want to talk to you guys about today is unlocking the power of additive manufacturing with physics-based software tools. And coincidentally, that is also the mission of our company, unlocking the power of additive manufacturing with physics-based software tools. Why that particular mission? And I break it down in kind of two components. On one hand, we have, and I think we all intuitively grasp this here, this enormous potential of what additive manufacturing can bring from a circularity perspective, from a manufacturing flexibility perspective. And that's kind of up here. And then we have what we can do today, which is already amazing, but there's a big gap between those two things. In the polymer world, you can think of the world around us that everything flows. It's just a question of time and temperature, which is basically the foundation. This concept is the foundation of rheology. And if we understand how things flow, why they flow, and if we understand the physics behind material deposition, then we can start to really unlock this gap in potential between what could be and what is. And why would we want to do that? Well, this lack of understanding of physics really handicaps us in many different ways. This picture is an extreme example of overheating in a 3D printed part, in a large scale, robot printed, 3D printed part. But it's just an example of all the problems that we get from not understanding this physics. We get warping, we get cracking, we get things that you guys have experienced many, many times over the course of your careers in additive manufacturing. In metals, but in particular I'm talking about here in thermoplastic materials and polymers. So when we understand that, what can we do? And this is a buzzword or a buzz phrase that we use in the industry, but I think it is, I can't think of anything better, any better way to say it. And that is when we master that physics, we can unlock first-time right printing, which means we can go from a true digital representation of an object to a true and perfect enough physical existing object. And that's kind of the holy grail for us, right? If we don't have to do a huge amount of net shape manipulation at the end, if we don't have to do a huge amount of post-processing, but can go straight to a physical copy of the digital object. In this picture, this is, for instance, one of the robot printing platforms that we work with, but we also work with desktop consumer and desktop industrial. For us, it's a whole range of material extrusion. So how can we achieve this first time right and many other benefits? Well, let me introduce Dragon, which is our no-code cloud-based process optimization tool. Dragon includes three components: extremely fast cloud-based first principle physics-based thermal simulation, a set of physics models and material libraries to translate that thermal simulation data into something real, and then finally a set of optimization algorithms to bring that loop to a close and really output something that's worthwhile and that makes this first time right printing achievable. We do this in 3 steps. We pull in toolpathing information from whatever slicer or toolpath preparation tool you're using, whether it's Fusion 360 or other tools, and then we pass that through effectively no-code thermal simulation tools, physics models, the optimizer, and then get out an updated toolpath that allows a whole lot of benefits once you understand the physics of what's going on with the material. For me, when I think about where this fits into the big picture, on one hand we have toolpathing, and we talk a lot to toolpathing companies, and I'm in awe of the mathematics behind kinematic robot simulations and toolpathing in general, and that's its own art form and really exciting. That's like left brain here, what's on the right. Very exciting, very powerful. We don't do that particular side of things, but we believe there's a complementary side, a second half, a right brain that is needed to really deliver on this promise. And that right brain is the physics-based, first principle-based process optimization that we're offering. And once you have both together, now all of a sudden real magic can happen and we can do a lot of cool stuff. What we can do is we can go from something like this to something like this without having to actually print a part and make process parameters, adjustments, trial and error. We can do all that immediately in the digital form. We're currently working with the first customers, and it's really exciting to get those first feedbacks from real-world parts where people go, okay, well, can you try this? And then we pass them an optimization, and all of a sudden they're printing it without any trouble, and then they get super excited like kids in a candy shop, and they say, oh, we've also got this object. Can you do this one for us as well? I say, yeah, no problem. So our system integrates into the toolpathing software stack that those companies are using, whether it's a Rhino Grasshopper stack, whether it's other commercial platforms available, and then effectively pulls that toolpathing data out into the cloud and sends back an optimized version. The result so far has been, most importantly, first time right, because if it doesn't print, then what's the point? But also we see consistent speed increases. This definitely depends on how aggressive the original settings were, but in a recent part we had a 30% speed increase, and I think as parts get more and more complex, we can push that even further. We also get consistently better part performance, whether it's less warping, whether it's less deformation in the part, or tensile strength, as layer bonding improves and stress relaxation or stress decreases, stress relaxation improves as well. To close off, I'd like to end where I started and just leave you guys with one thought when you go here, and if you think about us and unlocking that gap in where 3D printing could be and where it is today, and that is to think about how everything in our world flows as a function of temperature and time. And when we understand the physics behind what's going on with the material, now all of a sudden we can make real magic happen. Thank you very much.
Thanks, David.
There you go, Phoebe.
So, Phoebe, the stage is yours. I'm very excited to hear about circularity. I think this is a great concept that you're going to introduce to us today.
Can you all hear me clearly? Good. I'm guessing yes. Thank you very much, Stefan, for the introduction, and thank you very much to the organisers for inviting me here today. Yeah, it's a privilege to be at a real event with real 3D, if I may say, people, and B, it's also a privilege to be surrounded by 3D printing and AM experts when I'm myself external to that sector. I'd like to start my session with a quick poll. I'm hoping this will come up somewhere miraculously with the Slido. Aha, brilliant. So if you can grab your phones, and I would like you to key in a word or keyword that you most associate with circular economy. And hopefully this will materialize into a word cloud. Okay, interesting. Oh, European Union, sustainability. Okay, keep it coming, keep it coming. I know it's after lunch. The lunch looked pretty good. Cradle to grave, okay. Reusability, carbon dioxide, costs, efficiency, closed cycle. 5 R's, thank you for whoever contributed that. We will come to those. In fact, they've increased since it's more R's now. LCA, yeah, life cycle assessment. Reuse of materials. Yeah, brilliant. Anyway, keep that coming, but I will have to move on to my next slides. But hopefully I will encompass some of these terms in my short talk. And I'm glad to see that you seem to be interpreting this pretty advanced level. There are many, many definitions of circular economy out there, but I'm choosing one which is very much recognized today by the Ellen MacArthur Foundation. It's pretty much one of the sort of thought leaders and toolboxes on circular economy. This is not the full definition, it's an excerpt. And I like the way they mention driven by design. That's actually my bold. I'd like you all to see these 3 principles of circular economy and think, well, how could AM integrate them more or at all? I think, many of you are already thinking about these topics, materials, CO2, etc., as you mentioned, as you put in the Slido. But how could you do this even more? Circulate products and materials, keep them in the economy, keep them in their cycles. Eliminate waste and pollution, obviously, ideally. And regenerate nature. I think for many of us that's still a little bit utopian, but ideally that is what we need to be doing. I like to use an example. Now, it's spoiler alert, it's not tech. I think you have enough of those outside, or yesterday at the flying dinner, there were many from Amber that you could admire during the dinner. I'm choosing a local example. I live in Berlin, and for me, this is the beginning of a transition to circularity. And it's the Nochmall in Berlin. It's about 8 kilometers from here in Reinickendorf. Do pay it a visit if you have a bit longer in Berlin. And it's also funny, German humor. Yes, plenty of German humor in Berlin, really. And Nochmal. Nochmal in German means again. So it's like the again mall. And it's actually an inspiring example of circularity also because it's a sort of fairly innovative business model. It's a waste management company which is going into retail. Now, that doesn't happen so often. And in effect, BSR, which is the Berliner Staatsreinigung, which is the waste management company, they're basically taking all this stuff that Berliners don't want and they're selling it back to Berliners. So it's local, less transport costs. Anyway, interesting model for you to think about. And that strap line is alles außer neu. So everything except new. Now, of course, we need new materials. We need new objects, products, new prototypes, etc. Of course we do. But we also need very much to reuse the stuff that we have, the products we have, the materials that we have already in the economy. And we're just not doing that enough today. So, a bit more theory. Today, we basically are in a linear economy, as we call it. The take, make, waste model. So again, it's a simplified diagram, but effectively we're extracting resources down here on the left, and we're making components and products. We're selling them, we're using them, but unfortunately not for very long. And that's to ignore packaging, which is often used for literally a few seconds. And that all ends up generally in industrial waste or household waste. It's a huge loss of value, not to mention resources in general. And as a result, we're having fewer and fewer primary materials. As you know, it's harder and harder to get hold of them. And more secondary materials, waste, which is often not being turned into secondary materials enough. So e-waste, which is a massive stream, it's one of the fastest growing waste streams in the world. Between 50 and 60 million tons are produced every year. That was in 2022. How could we use these better? And how could AM perhaps try and capitalize on some of those materials instead of having to go and get them from far away? And we are, however, developing more and more new materials, very, very exciting stuff going on all over, from plants, algae, fungi, even human waste materials, which I won't go into too much after lunch. So we need to transit to a circular model, a remodel, if you like. So one of you mentioned the 5 R's. So it's repurposing, refurbishing, remanufacturing, refusing. Recycling, actually, is a last resort because you've got a much greater loss of value. So you really want to be more at the bottom of that circle. So how could additive manufacturing be much more present in the bottom of this circle? It's a question to you. The title of my talk was in the form of a question. It's also made sense because we're closer to the discussion. Something for you to really think about in the next, in this afternoon, in the rest of the forum. On the left, we have regeneration. That's harping back to the definition I gave you earlier. Ideally, we need to be regenerating resources that we then, need to make products and services. Yeah, and I've shaded that out, the extract raw materials. I mean, we're going to keep needing new materials, of course, but we need to use a lot less of them. Awareness of circularity is growing. It's slow. Actually, Germany was the first country in the 90s to legislate on circular economy. Back then, it was very much a focus on recycling. And as I showed you, that is actually really a last recourse. Yeah, but since then, that's evolved, and we're much more looking at eco-design upstream rather than downstream. Now, every January, some of you may have heard of these, we have the Circularity Gap Report. They come out measuring the global economy, and so all the kind of flows of resources coming into the economy and going out again. I'm afraid it's a bit depressing reading because effectively the global economy is only pretty much 7% circular. So there's kind of a lot of margin of progress there. But however, what you measure, you make visible. So slowly, we are much more aware that we need to go more circular and that we are wasting a huge amount of materials, which just doesn't make business sense. It doesn't make environmental sense. It doesn't make sense in any way. Yeah, and we need to move away from inbuilt obsolescence. I think some of you mentioned obsolescence earlier, also this morning in the opening talk. So we've got these new metrics, which are slowly being developed. They're not perfect, but they're perfectible. At least they exist. And cities, countries are measuring their circularity. Munich and Stuttgart, they recently launched their Circularity Gap Reports. Munich last November. I was there for the inauguration, for the launch, really interesting. And companies are doing this. Now, for you, this is really interesting because companies are having to show circularity. There's a directive that's coming, the CSRD directive is coming in, where companies, the biggest European companies this year, are going to have to start measuring their circularity and reporting on it next year. So, this is all happening, and this is a huge opportunity, I think, for AM. So this is a bit more detail about the different strategies. On the right, I don't have time to go into detail, obviously, in 10 minutes, but where could AM fit in more here than it already does? Open question, for discussion later. Many companies are out there already developing circular models using one or more of these different strategies. You've probably heard of some of them, Fairphone, Grover, quite well known, Back Market, French, no longer startup. And they're not all companies. Some of these are also platforms like Fixit, iFixit, or different forms of organisation like tool libraries, usually run by city councils, probably, or volunteers. That could also be an opportunity for additive manufacturing. And I chose an interesting French case there. It's a small company in southwest France, in Bordeaux, and they use fish skin waste to make high-end leather products that even I couldn't probably often afford. So it's just really interesting. All sorts of companies out there doing really interesting things, using really interesting, innovative materials that I think AM could could benefit from investigating. A few examples I selected. As I said, I'm external to the world of AM, as you can probably tell. But this one I found interesting on mobility. It's the Refactory by Renault, French car manufacturer. Now, they had to close down a plant 4 years ago. Not economic. It wasn't it's not economic anymore. And they closed it down, turned it into a refactory. The French occasionally do like to use English. For the name of their company. And basically they are reconditioning cars. It's a training site. It's a whole ecosystem around circular mobility. Really amazing. Well, it certainly inspires me a great deal. And they're using, of course, 3D. They're using AM for unavailable parts. And something really to look at closely. AM on demand. Yeah, this is a nice and interesting example by Script Hero, which is a brand of BASF. Now, it's sort of one-stop shop online where you can order, you've probably all heard of it. And what's it doing in terms of circularity? Well, it's already there, but there could be much more. They could offer many more different types of material, different types of process that might be more circular. and I see my time running out. Construction, I know this sector is not so well represented here, but yeah, what's really interesting is that they're using local materials, so local raw earth in Italy, and they're printing a house using this material and using local building practices. So yeah, sort of global with local. I must finish. Thank you for your patience, and I hope you followed me. But yeah, circularity and AM, I see that as a really symbiotic relationship. They can each benefit from each other. And AM can certainly help circularity to actually, to really happen, to make it more feasible. And I think for AM, circularity is just a swathe of opportunities. So thank you for your patience. Yeah, we don't have time for a second poll. And yeah, feel free to ask me questions afterwards or in the discussion, and I will pass you back to Stefan. Oh, I don't know if you got.
All right. Well, thank you, Phoebe. I think that was very insightful, and I think a fresh approach how we should look at AM. So we would now start a Q&A session. I really like to encourage you one more time to use the Slido on your mobile phone to pose more questions. There's already a number of them out here, which we're going to touch upon. But I'd like to open up the Q&A session with Tim. I mean, we have seen 3 very different concepts now with the platformization, physics-based software, and circularity, and we deliberately said, let's look at 3 different concepts and technologies and investigate how they can help the AM community and, most important, the customer to create more value with it. Now, from your very practical experience, because you're working as a consultant day-to-day with important customers, asking themselves, how can we make use of this whole stuff, right? So it'd be very, I guess, interesting to get some insights from your day-to-day work. Maybe you can comment.
Yeah, thank you, Oster, for having me here. So our clients usually, especially in the AM business, they like to grow on a sustainable business. Not that their stock value is plummeting, as the example that we've seen. So it's a business where we grow double-digit, and this is typically, compared to other industries, a unique setting. Yeah? And this is the AM industry and the AM spirit that needs to drive that further. However, if we look at you guys here and the market data, not everybody can make a profitable business from that double-digit growth. And it's all of these hurdles that we've today heard, mean it platform, mean it software, mean it the things that appear to be little, but then in the end make the parts fail. It's the sustainable business and the circular economy. It's all the new challenges that our clients are facing currently, and of course, we as Roland Berger try to help them as much as possible to get over these hurdles. And I think it's these 3 concepts that represent an entire, let's say, community here to bring down that the engineer, that the user, that gets less and less hurdles to get the AM part adopted. Because I think AM needs to be better than the conventional techniques to show the additional value. And therefore, I'm really happy that we have this community here and the 3 examples here that really make it easier, make it cheaper, make it faster, and develop new concepts. Yeah? So this is also what our clients give us on a daily basis as feedback.
Okay, so you're really encountering that need about the technologies, the concept that we've been talking about in the market, which I think is quite interesting, and that also why we put this up on stage today. Okay, that's great. So let's maybe look into the questions that we have on Slido. Maybe from the first question, there's this word of protectionism that strikes me. You know, I think it's interesting that we are in an innovative industry, and we're trying to protect ourselves or our technology or maybe our customers or customer relationships, and then there's still this aspect of collaboration, you know, in an open B2B platform. Now, I mean, having a platform, having that protectionism sounds like you know, it doesn't work together, you know. So how do we overcome this protectionism? And I think that may be a good question for you, because I think what you guys are trying to do with the platform is to open it up, you know, and make that benefit and that value available to everybody out there and becoming part of the value creation. Is that about right?
Yeah. Gregor is probably Gregor Graf, maybe our team here. But I think the industry is just not mature enough to do real manufacturing. I mean, if you can't buy a CNC machine and then get told you have to buy the raw material stock from the machine vendor, and then you have two settings. One setting is accurate and slow, and the other one is fast and crappy. I mean, that's has been a state of the industry. It has changed over the last years, but I think it will just change over time when the mass industry cases are coming, and for that the unit costs will need to come down. Otherwise, we will never scale. And that's what I tried to bring over in my presentation. We need to scale the industry, or we will just be the happy AMAG after our people in 20 years, just with a lot less hair, maybe. That's kind of my point.
Okay, great. Maybe I also like the second question. It's always the sustainability and greenwashing thing, right? That always, tends a bit to come up. Is that something that when you talk about circularity that you encounter a lot? And I mean, what's the right recipe to make people aware of the concept of circularity? In customer conversation, I sometimes feel customers much more advanced in this sometimes than maybe the AM industry. So with the benefit of the outside view, how do you feel about that?
Yeah, greenwashing. Actually, in my line of activity, we talk also about circular washing. You have all these different kind of washings these days, and I think in Corona times that really grew massively. This whole sort of greenwashing. We need to be aware of this, and I think customers are becoming a bit more savvy. Also, with the exchange of news and online, one can find out information quite quickly. However, it is up to regulation to support that, where where claims that are made really are verifiable, and that is actually coming in terms of regulation recently, where it's becoming more difficult for greenwashing. But I think it's more B2C rather than B2B, which I think it should also be included, but that's going to take a bit longer. One has to just be more critical, and for consumers, end consumers, it's harder. But I think as people become more aware of what circular economy actually means, that should become easier.
Yeah. So I can jump on this. From our clients, it depends on the industry that you're in. Of course, some of the industries are quite fast forward, and there's a cycle. Some of the industries already they pay a premium. If your products, if your printed products, if your delivered goods have a better CO2 footprint, they pay money for that. Certain industries, they don't care at all yet. But at some point in time, they will also might change that. Yeah. And in some industries, if you're not more sustainable, you will be simply out of business. I mean, this is then it's not greenwashing anymore, but it has an economical, let's say, perspective to that. And I think additive manufacturing as an industry is digital. We can do better. In terms of, let's say, putting the prices of CO2 and how much is in there, and we see that it is improving, especially in the last 2 years. We've gotten a lot more better, and it's also with the development, with the software that really brings, let's say, and accelerates that here to make that better. Yeah?
Yeah, maybe to add to that as well, because I think it's a topic that touches really all of us. A few years ago, when we started Helio, I got in touch with the father of the triple bottom line concept, who we'd done work with in the past, John Elkington. And I said, John, we're working on this. I think, it will really help 3D printing scale, and that's a good thing from a sustainability perspective. And he said, are you really sure that 3D printing is itself good from a sustainability? Right? And I was pretty defensive about it, and I said, what do you mean? He said, well, I'm not saying it's not, but can you prove to me that it is? And I think we have two lenses here. One is the lens of, can we, reduce powder waste? Can we reduce, use green energy for what is effectively an expensive oven, right? Which is what the 3D printing process is. But then there's the other lens, which I think is way more powerful, which is how do we disrupt traditional manufacturing and all the waste that's involved there, right? And I think it's up to us as an industry to focus more on the first and put the numbers behind the first and put in those life cycle assessments and those, it's like, what did BYD say recently? They said, Tesla is not our enemy is the internal combustion engine and traditional auto. For additive manufacturing, the enemy is not other additive manufacturing, but rather traditional manufacturing that we need to somehow, grab market share from.
Yeah. There are two questions about, and maybe that's more of a clarification on platforms, right? Is it any different from a traditional software platform? What you're trying to do, and how does it affect supply chain and logistics? And maybe it's more of a clarification that we need to do here. Maybe could you comment on that?
Oh. But traditional software platforms is interesting. It depends what you mean with traditional software platforms, or what you mean with other industries. I mean, if you look at other manufacturing industries, I would say additive is pretty good. If you look at subtractive, the state is really bad. I mean, Autodesk recently invested in CloudNC, which is a cloud automation platform with AI, and their pitches, which made me really crumble, is let's make subtractive manufacturing work as good as additive manufacturing. That's their startup pitch. And what they, of course, mean is that subtractive is a lot more manual, there's a lot less digitization, and additive is not so bad in that sense from a platformization perspective, even if we don't think about it. We have other problems from scale and from maturity and all those kind of things, but from digitization it's not so much. If you think other industries like the phone industry or so, you're just light years behind in terms of scale, in terms of resources that went into, in terms of all kinds of other things. So it depends a lot on the context, I would say. And the other one, global supply chains. Yeah, I don't know. It's too early to say.
I mean, this is then an aspect that comes from a software platform, goes into an online parts platform. We have examples sitting here.
We have sitting in the first row, yes. But I think it's also too early. It's all a maturity thing, and you really need to get insight into the process. And the insight into the process cannot be what layer you're printing. I mean, I really appreciate the OPC or standardization of the VDMA. But if you want to do a really, really digital twin, you need to get much deeper in the process. And that is only slightly happening with the commercial machine vendors, and it needs to go a far way until a digital twin will tell you anything if the part is actually flyable or whatever. So maybe you should ask in the first row how that's going.
Yeah. Do you feel that there's enough collaboration in the industry, maybe coming from the hardware vendors, because they were the first ones to really pick it up on the industry? Or is there, should there be more open?
But it's all a business decision. If you only sell 10 machines, it's very difficult. You need, the business model needs to work, and for business model you need scale, and for scale you need business model. So it's a lot of hen and egg problem, and everybody was so happy about hearing aids 10 years ago, and everybody thought that we will have a hearing aids every 3 months, and we didn't. Yep. So that's important. And I think what really needs to happen is, maybe that's also to the standardization thing. Standardization is great and important, but I come from a service bureau background, and I think cost is much more important than standards. Because if you can't match the costs, you can have standards as you want. And if you match the costs, you will make your way without standards. And standards are important on the tail end of mainstreamization. But at the moment, it's good that we're starting it, but it will not change the game, in my opinion.
Yeah. Maybe thanks for picking up the point about the standardization, because that's really igniting the audience. Maybe if I rephrase that a little bit, David, with regards to the physics, is software the right way to handle the standardization in a way? So you have it implemented with the first time right, and making sure you got the right standards already there?
Well, I think when you have a strong enabling technology, right, that supports standardization across the different tools that we use. And I think understanding at a physics level the process of what you're manufacturing is really an enabling technology for a whole lot of stuff. So once you kind of get that critical milestone or that watershed moment where all of a sudden the basic things are, it's like a Maslow hierarchy of needs, right? The basic, you've got shelter, you've got food, you've got prints that don't warp or crack. Now what can we do on top of that? And I think that does drive standards, because now all these other people who are building, like, I think generative design, for instance, which is an amazing group of technologies, but you really need this foundation first before it can come into its own. And so from that perspective, I think yes.
Okay, great. I think we're pretty much at the end here. I think there's still questions coming in, but maybe we can do a very quick round, like we're talking about takeaways from the session, like from your perspective. I mean, Tim, you like to start?
Yeah, so I think we're all struggling to make really business from the good goals, and I hope that everybody can participate in one or two things to make the hurdle a little bit less for all of us, meaning price, meaning time to market, meaning good parts, meaning shrinkage, and even more and sustainable business models to create the additional value wherever the business case, the AM business case, is maybe not as favorable, to make it a little bit better.
Yeah, it's exciting to hear about Autodesk strategy on platformization, and I think seeing how we can connect different pieces. We also integrated or started our Fusion 360 integration process last year. And yeah, it's one of those, when you look at mega trends or when you look at drivers in the industry, it could go one way or the other, and there is no one future. But it's exciting to see one of those futures painted and then to have a chance to follow through with it.
You want to respond to this?
Thank you. I wanted to thank you that we wasted your time. I hope not. I hope you took something away. And if, I really think, I wanted to end with a positive note, and I think there's a lot of bad mood in the industry because the money went away, and now everything is AI. And AI has a place in additive, and it will rescue a lot of things. And I think we are still just at the beginning. I mean, if you just look at the space sector, I mean, you can't go to Mars without additive. It's very open, very clear. And a lot of things will happen if the economics are right. That's the major hurdle.
Phoebe.
I think I would say that AM is by its nature disruptive. So is circularity, and there's so many gains to be had from them. Sort of working much more together. Yeah.
All right. Well, this will conclude the masterclass for today. It was my great pleasure to have you on stage and prepare this with you. I think that was very insightful. I learned a lot certainly today, and I really appreciate that you all joined us for this session. Hope you had your couple of takeaways, and you guys are all going to be around. So if there's additional discussions, then you're available. So thanks again.